MIT and AMD have been friends. We've worked on so many things together, and we're so excited to think about a partnership with you in the future. Please welcome.
Yeah, thank you, Daniela. You know, it's a pleasure to be here, and thank you for hosting us over here today to the fantastic launch event. Quite excited to see a team like Liquid come together and really make the jump from research into the startup era, and we've got a lot of good things we can work on together. AMD Research and MIT has been, a strong partnership over many decades already. And we're very excited to collaborate now on the AI research as well. We also have a lot of MIT grads coming to AMD. There's actually a big facility right up the road here in Boxborough. AMD still does significant processor design right here in the Boston area. So all our big CPUs are designed over here, the cloud CPUs. And so we really could not be filling this talent pipeline without the strong collaboration between MIT and AMD.
So, Ralph, can you share with us the range of products AMD is focused on as one of the leaders that is building the substrate for AI?
Yeah, no, that's a really good question. Yeah, so AMD is actually a full portfolio. We go anywhere from the cloud, high-end GPUs that are really used to train AI models, CPUs, so the Instinct line is the GPU line, the EPYC line is the CPU line. They really power all the data centers around the world, and they also sit in supercomputers and national labs. We also have the gaming GPUs, and there's a lot of AI going into gaming now. And on the client side, so all the laptops that you're running, those are our APUs, right? Those are SoCs that are mixing of CPUs, GPUs, and now also NPUs. And then we also have the embedded product line coming in from the Xilinx side, where we get into close to edge, close to sensor applications, really highly efficient, and it's really ubiquitous in all kinds of applications, right? Whether that's factories or cars or healthcare, it's actually quite diverse, right? So AMD really has processors for all market segments that are powered by AI now.
So all the way from the clouds to the edge. Kind of like how we think about AI, all the way from big models to small models.
Yeah, and it's interesting right now, right? So we're in, the models are being trained on these big GPUs. The big GPUs are quite power hungry, right? So they're sitting around a kilowatt per GPU. And we train scaling to hundreds, if not thousands of GPUs, right? So these big training data centers are sitting in the megawatts of power. Right? And we heard about talk about scaling, right? How far can we go before we run out of or hit a plateau? The scaling continues, right? And we're going to see data centers approaching the gigawatt power usage, right? So we're getting into training clusters in the tens, if not hundreds thousands of GPUs, right? So that scaling is definitely alive and well. In the end, it's going to be energy efficiency that's going to enable further scaling over there. That's a real problem.
Yeah, I mean, in fact, energy efficiency is also one of the drivers of the work at Liquid. Traditional AI models cost so much in energy, and they have a huge environmental footprint. We are very interested in more energy efficient approaches. So can you give us some statistics on the energy cost of AI for development and deployment?
Yeah, that's also why we're really excited to be partnering with Liquid. On the cloud side, as I said, it's 1,000 watts per GPU, scaling to hundreds of thousands of GPUs, so you're getting megawatts going to gigawatts, right? On the client side, your laptop, that can't burn more than tens of watts, right? So 50 watts is already fairly power hungry, right? The actual processor inside the laptops sits at 10 watts or below, right? So now you got a single GPU at 1,000 watts in the cloud, and you got an APU sitting there at give and take 10 watt power consumption, and the actual NPU inside your laptop, the neural processing unit, is in a single digit watts unit, right? So it's quite a range we're dealing with over there. Now, The innovations we contribute is process technology, processor architecture. We're building specialized processing fabrics for training. We're building specialized processing fabrics for inference, right? But the contributions the team Liquid is making are tremendous, because we also have to simplify the models, shape them, make them efficient. This is all very important, right? So anywhere from actually training the foundational models is important. The contributions you make is really great. But then also the broad market is taking the models and is fine-tuning them for their uses, right? So the models have to fine-tune efficiently as well. And then we have to slim them for very low energy efficiency, high energy efficiency, low energy consumption on the client side, right?
That's so exciting. Listen, I just want to move through a few other topics before our slot comes to an end. Can you tell us more about client and embedded products and how they impact your revenues?
Yeah, so now, of course, I got to be careful what I say. I'm not the financial representative of the company, but if you look at public quarterly reports, you'll see that we are sort of balanced between the cloud side, the client side, and the embedded side, right? Now, the current fastest growing segment is the cloud, because we're pushing into really more training and deployment. The actual models are trained on a GPU, they're deployed on the same GPU, right? Then they get optimized for client. What we're really seeing right now is we're in the cloud wave. When a human client or human actor interacts with a virtual agent in the cloud, right? That's the wave we're going through right now. Tremendous growth. We're all seeing it, right? You see what the GPTs of the world can do. You see what the Liquid foundation models can do, right? It's quite amazing, right? The second wave is really starting. It's coming together. It's the personal AI getting onto the client side. It's laptops, it's tablets, it's your phones. So that wave is starting to take momentum. But we think that the third wave, when we get into the physical world and we get into humans interacting with physically powered AI agents, and also physical AI agents interacting with other physical AI agents, that'll be an equally big wave, right? So currently we're seeing that as balanced. There's a trend to cloud right now where we think the client side as well as the edge embedded side are equally important.
That's just so exciting. I can really imagine so many applications on the edge, in addition to all the many applications in the cloud. But let me ask you this. As the AI models grow in size, are there innovations that are needed in chips to cope with that?
Yeah, no, certainly. Right? So we're seeing the AI models growing in size really needs a lot of communication technology. If you look at our high-end GPUs, they're about just as much about the compute as it about the IOs, the SerDes. So we have more than 100 high-speed SerDes on a single GPU, and we really network them with other GPUs. So it's all about networking technology and that enables that scaling. Whereas this on the client side, battery-powered environments need to be extremely energy efficient. And over there, we are actually building a neural processing unit that is just focused on energy efficiency, right? And then you can take it all the way to the edge side. We're sitting there with our programmable logic fabric, and programmable logic allows you to completely customize your neural network model. You co-design with the hardware itself, and we're really bringing very low precision. We're talking about binary, ternary neural networks onto edge applications with extremely high forms of sparsity, right? The human brain is somewhere between 5 to 6 orders of magnitude more energy efficient than what the cloud hardware we're building. That has to come from somewhere, right? So there's a lot more innovation we can do together, and that's on the Liquid side, but it's also on the MIT side.
On both sides, on the science side and on the entrepreneurship side. So we have time for only one question, and I have to ask you about Liquid. So what is the core reason you think Liquid technologies and products are attractive?
Yeah, so again, I think as was stated many times today, right? We need to bring the efficiency up. We've got the scaling problems. Transformers in the fill phase are fundamentally memory bandwidth bound. right? Driving that efficiency is really important. Bringing, scale and making it scale differently is really important. And that just will enable so much more pervasiveness of AI, not just in the cloud where we have the high bandwidth, where we have the high-speed I/Os to scale to many devices. We have to make it efficient for bringing it into everyday use of AI, into the personal space, and also into the physical world, right? And that's really where Liquid's focus on energy efficiency in the models is really important for us.
The interplay between AI body and AI brain is so important to AMD, to Liquid, and to advancement in AI. Thank you so much for sharing your thoughts with us. Let's give Ralph a big round of applause.
Thank you, Daniela.
Thank you.
That was great.
Thank you.
Thank you.